Deploying state-of-the-art multimodal AI creates an immediate tension for developers. You can have top-tier model intelligence, but once you put it into production, you hit a brutal wall of latency constraints and prohibitive compute costs. Microsoft's April 2026 announcement addresses this specific bottleneck. They rolled out 3 new models in their suite: Transcribe 1, Voice 1, and Image 2. These models are available exclusively through Microsoft Foundry and the MAI Playground ecosystem. If we look past the press release framing around humanist AI, the actual engineering strategy here is highly pragmatic. The true strategic priority is pairing aggressive API pricing with massive throughput multipliers to make high-volume execution viable. We can evaluate this by looking at the FLIR's benchmarks, raw throughput data, and token economics to see exactly where these models sit on the cost-performance frontier. Prioritizing inference throughput over parameter count targets the specific overhead that usually prevents multimodal AI from scaling. Starting with the speech-to-text modality, we have MAI Transcribe 1. This model is built to extract clear dialogue from messy, real-world acoustic environments. Its primary performance metric is an average word error rate, or WER, of 3.9%. That figure is evaluated across the top 25 most used languages, according to Microsoft's own product telemetry data. This chart compares the 3.9% against industry baselines. Transcribe 1 leads, with Gemini 3.1 Flash at 4.9% and Whisper Large v3 trailing at 7.6%. Filtering this FLIR's benchmark data down to 11 core languages, Transcribe 1 holds that first-place ranking. Looking at the remaining 14 global languages in the test, it consistently overtakes the previous Whisper Large v3 benchmark. Accuracy only matters if you can process the data quickly. The traditional bottleneck here is inference latency. Transcribe 1 includes batch processing optimizations that yield a 2.5 times transcription speed increase over the legacy Azure Fast tier. The enterprise API cost attached to this speed starts at 36 cents per hour of audio processed. Delivering a sub-4% error rate is an engineering feat. Doing it without the standard enterprise latency penalty makes it viable for production. Moving from input to output, we look at the generative audio model, MAI Voice 1. Its primary utility is generating natural, nuanced speech that maintains a strict emotional range. It features zero-shot cloning, meaning speaker identity is preserved using only a few seconds of input reference audio. Historically, sustaining that specific emotional consistency across long-form audio generation requires heavy computational overhead. This timeline interface illustrates MAI Voice 1's defining architectural output metric. A single second of compute time expands into 60 seconds of continuous audio waveform output. Highly efficient GPU utilization explicitly enables this specific speed-to-quality ratio. That throughput efficiency flows directly into the pricing model structured for developers. The operational cost is strictly $22 per 1 million characters generated. A 60-to-1 compute ratio removes the primary economic barrier for businesses attempting to scale real-time voice agents in consumer applications. Finally, we evaluate the visual modality with MAI Image 2. Its baseline quality metric is established by its immediate placement as a top 3 model family on the Arena.ai leaderboard. The architecture targets persistent design pain points, ensuring accurate skin tones, natural lighting, and organic texture. For enterprise workflows, its defining capability is generating clear, accurate, in-image text for diagrams and graphical layouts. Image generation typically suffers from severe latency constraints, but this model drastically cuts those waiting times. Based on real-world production traffic, it registers a measured 2 times faster generation time on the Foundry platform. This flowchart details the bifurcated pricing structure for these visual API calls, splitting into 2 distinct cost streams: $5 per 1 million input tokens and a larger $33 per 1 million output tokens. Its production readiness is already validated by active, at-scale deployment within the global marketing group WPP. Generating clear text at twice the standard speed makes Image 2 a viable production tool for high-volume graphical workflows. The technical thread connecting Transcribe 1, Voice 1, and Image 2 is a deliberate refusal to chase parameter bloat. Instead, Microsoft targeted the triad of actual production bottlenecks: inference latency, API cost, and narrow utility accuracy. This matrix plots that baseline shift. When mapping modality, API cost, and throughput speed, you can see all 3 MAI models grouping tightly in the high-speed, low-cost quadrant. The deployment framework for these models remains strictly confined within Microsoft Foundry. These raw performance and pricing metrics are inextricably bundled with necessary enterprise-grade compliance and built-in red teaming governance protocols. By altering the cost-to-throughput ratio, Microsoft forces technical architects to recalibrate their baseline expectations for what state-of-the-art multimodal AI should cost to deploy at scale.